is LeetCode problem number 3242, design NeighborSum service Python solution. But before we discuss, please like, share, subscribe and hit the bell button for notifications. Also, I have added a lot of C++ quizzes to the community page. Please check it out. Now back to the problem, design NeighborSum service. So basically we're given a n by n 2D array grid containing distinct elements. So this is the key. The elements are distinct, they are unique, and now you are supposed to calculate, like when they were given an adjacent number sum of a given number, then you are supposed to, like in this case 4 adjacent sum, then you need to calculate the top left, like if this grid is given, like let us, yeah, okay, so let us, if it is given 4, then you need to calculate the adjacent sum as sum of 3, 1, 5 and 7, which is 16, and diagonal sum is 0, 2, 6 and 8, so that is also 16. So this is what you are supposed to return. And let us take a look at the Python solution. So the NeighborSum is the first, the initialization is there, wherein you initialize with the initial grid given, and then you, because you are given the grid like this 0 1 2 3 and you are asked 4, you don't know where 4 is, so you don't want to search each time, so you need to you can create a mapping, like 4 is in position x position of 1 and 1. Like if you say it is row number 0 and then row number 1, and then 036 is column 1 and 147 is column 0, 036 is column 0 and 147 is column 1. So the fourth position is, the value 4 is in position 1 1. So that's what you are creating in this function. You have a new grid value to position, and so grid I comma j, you will store the tuple 1 comma 1, in this case of 4. So when the adjacent sum 4 comes, then you just check if the value is there or not. If the value is not there, then you return 0. So like in this case 4, adjacent sum of 4, you check whether 4 is there in the mapping or not. Otherwise you get those x positions, and then you calculate the adjacent positions, x minus 1 y, x plus 1 y, x y minus 1 and x y plus 1. So those are the adjacent positions, and then you initialize total sum equals to 0, and then you go through these adjacent positions and then make sure they are within the parameters of the grid, and then add the sum and then return the sum. And similarly the diagonal sum is also there. In this case the diagonal sum is x minus 1 y minus 1, x minus 1 y plus 1, and then x plus 1 y minus 1, and then x plus 1 y plus 1. So you go through the exact same thing and then make sure they are within the grid, and then you calculate the total sum. So let us take a look at the run for this. So 0 4 6 sorry 0 1 2 3 4 5 6 7 8 kind of grid, and so you initialize, see, you map position 0 to 0 0, 1 to 0 1, and then 0 2, like that you do until 2 2 4 8. Now you can, for calculating 4 is position found at position 1 1 in the map, and from there you calculate 1 from position 0 1, and then 7, so you get 1, and then you get 7 here, and then you get 3 here, and then 5 here. So those are the adjacent neighbors, adjacent sum, and then you add all of them to get 16. And similarly for diagonal sum, you get 0 2 6 and 8. So you get 0, 2, 6, and 8. So that is also 16. So that's how. So the time complexity is order of n square for initialization, and then O of 1, because you just go through the 4 positions, even though you are looping, but that looping is not order of n, because it is just only for, it's a constant 4, so that becomes order of 1. And similarly, the space complexity is order of n square, the grid, and then order of 1 for adjacent and neighbor. So that's the um, time and space complexity. Comment below if you have any additional questions. Otherwise, I will see you in the next video.